Welcome back. We are going to review the key ideas of every chapter. So the first key idea is that in physics we use units. Units to describe what is happening around us. What is happening is that the time is passing, there is length. So there is a length and there is mass of the object. So every physical property of the reality is measured in some units. And the unit of time is the second, the unit of length is the meter, and the unit of mass are the kilograms. So as a summary, time is measured in seconds, length is measured in meters, mass is measured in kilograms. So the second thing is that units have a consistency. For example, if you are going to talk about the distance, distance is measured in meter. So you don't know this V in what is measured. But if you say that D is V by T, there must be a consistency in the equation that say on the right side is meter, on the left side have to represent also meters. So let's say that D is 10 meters. Let's say that T is 5 seconds. So 5 seconds cannot be equal to 10 meters. Even if I put a 1 here, 1 by 5, it will not be 10, but also 1 with 5 seconds will be 5 seconds. It would not be 10 meters. So what is happening that here the V have units, and the units are meter by seconds. So what's happening is that this second cancel with these seconds. So whatever equation you have, the units have to be consistency. So D equal V by T. D is in meter, T is in second, then what is here have to be meter by second in a way that when you cancel, you will find meters equal meters. This is happening with every equation in physics. Consistency in units. Now we are going to review vectors. The sum of two vectors. The sum of two vectors given A, B, and C, three arbitrary vectors. How we sum vectors? When you think about vectors, you have to think about the magnitude and about the direction. The vector V have a magnitude, the length of the vector. And the vector V have a direction, this direction. What direction? This one, this direction. And very important is this direction, but going to the right. B is going to the right in the blue direction. The vector A have a magnitude, and the magnitude is this length, the length of the vector, and have this direction. What direction? This direction. It's another different direction. So A is going in this direction. A is going in this direction. V is going in this direction. Where is the sum? So when you think about the sum, you have to think maybe as a vector displacement. So what is the vector A plus V? So you imagine that you make a displacement. If you make a displacement from here to here, you are here. Now you make the displacement A. Now let's go to make the displacement B. If I make the displacement B, I'm going from here to here. So at the end, I start here and I end here. So I say, graphically speaking, that the vector A plus B is the vector that goes from the tail of A to the head of B. This is the vector A plus V. Okay. So, how we sum vectors? A plus B is a vector C. We call it a vector C. This is C, a new vector. And the vector C goes from the tail of A to the head of B. It has a different magnitude. And what is very important for C is not only that it has a different magnitude at A and a different magnitude at B. It has a different direction. So the direction of the sum, let's go to make a nice picture. So this is the A, followed by the displacement V. So this is the A plus V. This is the vector that goes from the tail of A to the head of B. You see that now it has another different direction, A plus V, than the direction of B. The direction of B was in this direction. The direction of A was going downwards in this direction. So A have a magnitude and a direction, this direction. B have a magnitude and a direction, this direction for B. And A plus B have another magnitude and another direction. A plus B. So this is the game that we are going to play. This is V. Now you have to recognize that making A plus B, making A plus B produce a new vector C that is like this. What if we do the in a different order? What if we make V first and we make later on A? It will be B plus A the same result? Yes. V plus A is the vector that goes from the tail of B to the head of A. Is this vector. And this vector V plus A is exactly the same vector that this one. Is the same one, the same direction, the same magnitude. That is why it's the same vector, because it has the same magnitude like this one, same length, and same direction. What is the direction? The direction is this direction. This direction is the same direction. So they have for both the same direction, so B plus A is the same. Commutative property is the same that A plus B. Now you will see this picture, A, B, C, A plus B. He didn't call it C, he called it D. A plus V is D. If I add D plus C, I will find the R. D plus C is R, A plus V is D. And what is R plus D? Is here R plus D? No. R plus D, you have to sum it. How you will sum R with D? Well, you will take the D and you will put it on the head of R. So this is the D in red. This is the D. I'll try to... the R plus the D will be this vector from the tail of R to the head of D. This is the sum, the R plus D. Okay, so see this picture. For example, if you see this one, A plus B plus C, A plus B plus C is the R. Here you can conclude that R is A plus B plus C. Okay. Now I have two vectors. Let's say the A and the V. I want to wonder what is V minus A. Who is V minus A? V minus A is the vector that I have to add to A to obtain the V. What vector I have to add to A to obtain the V? This vector. So this is the vector V minus A. Can we check it? Yes. A, you see the sum. We already learned how to find the sum. A plus this is this one. A plus this one, V minus A plus this one, v minus a. What it is? Well, the a cancel with the a. Oh, this is the v. It's correct. So how we find the difference of two vectors quickly? First of all, if I have two vectors, a and v, let's say a and v like this, how I will find a minus v? So I will put it together, the two vectors, the a here, the v here. The tail have two common points. So the a will share a common tail with the v. And what is the vector a minus v? The vector a minus v is the vector that goes from the head of b to the head of a. Ooh. This is the vector a minus b. Let's go to check it. V. You see the sum here? Do you see the sum? The sum this plus this is this. Okay, let's go to check. This plus this is this. So v plus a minus v is, cancel, is the a, is correct. Is the a. This one is the a. Okay, so two vectors, the difference, you put it together with the same tail together, and you join the head of one to the head of the second. If you make the R2 minus R1, let's say R2, vector R2, vector R1, and you wonder, what is R2 minus R1? R2 minus R1, R2 minus R1 is the vector that goes from R1 to R2, from the head to the head. This is the vector R2 minus R1. And now you can check if you want. You see now the picture R1 plus this vector gives this vector R2. R1 plus R2 minus R1 will be R2, of course. Is the same thing like here. If you wonder who is R1 minus R2, is the opposite vector, is the vector that goes in this direction. So we will practice this more clear. Now here is about component of the vectors. You need to know that the sine of theta is the opposite divided by the hypotenuse. The cosine of theta is the adjacent divided by the hypotenuse. And of course you need to realize that if this is 5, this cannot be 6. This cannot be 10. If this is 5, this is less than 5. And this is less than 5. And always here there is a rectangle, a triangle that is rectangle, 90 degree here. So this is 5. If this is 5, this is 5, this is 5, cosine of this angle theta. And this side, the amount of length that is here is 5 sine of theta. This is what you have to know, and we will practice in the practice quiz, we will practice how to find the component of the vector. Do not worry, but get this idea. What is the sine, what is the cosine, and think that this amount is 5 sine of 30, because sine of theta, sine of the angle, is x. This is x, the unknown x. This is x divided by the hypotenuse, but the x divided by the, so the x is the hypotenuse by sine of theta. So the x that we are looking is the hypotenuse 5 by sine of theta. So I didn't cheat you. This is the x. Okay. And finally, see how to sum vectors. Basically, you sum components through components. The argument why you sum component with component, ax with bx, is in this picture. If you analyze this picture, you will see that this vector is made of this plus this. So Ax plus Bx is the component of R in the x direction. And Ay, this part, plus Vy, this part, is the component of the vector. We will practice. So so as a conclusion, if you have A, like Axi, some amount of meters in the x positive direction, plus some amount of meter in the y positive direction. Maybe the amount of meter is negative, the component can be negative, so it go in the negative direction A. If you have V, some amount of displacement in the I direction plus some amount of displacement, positive or negative, in the J direction, what is the sum? The sum A plus B is always AX plus BX in the I direction plus, I write it here, plus VX plus VY in the J direction. And this is all that you need to know for the moment. See this picture, how the vector sum is made. A plus B is the vector sum. Okay, let's go to the practice on this chapter. Let's go to practice now the problems.